Okay, so today's study group will be on data cleaning in pandas. I've sort of like picked out the main things that you would be doing in a data cleaning process. Why I do recommend doing either of the mini projects from 4 or 5 is because you get to really like put that all together in like a single cleaning narrative. Whereas here, what I'm going to be doing is I'm just going to be like talking about, a technique in isolation and really drilling down like what this is for. So the main things I'll be talking about are map and apply. And map and apply, very similar to like what we talked about with lambdas. This is the other method that I actually use lambdas the most in, aside from all the couple others that we talked about the other day. So I'll talk about map and apply. We'll talk about Groupbys, joining data frames, and also what to do with missing values. So to start, I already made sure that I had this CSV in here. We import our NumPy and pandas. We're doing the same car data frame, the miles per gallon car data frame. And then we'll just quickly do a dot describe. And if you remember, dot describe is one of the like good inspection methods. When you first, get a set of data and you like don't even know where to start, dot describe sometimes really helpful. To go into a little bit more detail of what I look out for in dot describe is dot describe can be really helpful in looking for like outliers. So for example, if I see like the mean values are very far away from either the min or the max values, and of course you have to take into context, right? Because here you can see like weight, the mean is almost 3,000 and the max is like 5,000. There's like a difference of like 2,000, but you have to take in consideration like the units of weight. So we'll get more and more used to this, but looking at numbers in some context, so just so you don't say, well, like weight has the greatest difference between like the mean and the, the extremes, but relative to that, weight is measured on a larger scale. What does that mean versus something like, I don't know, cylinders? Like maybe 8 is an outlier, but yeah, just thinking about that in context. So that's something that I like to do when I look at dot describe. Just a really, really quick inspection. And then this usually feeds into a little bit more visualization or a little bit more like specifics, which you'll get into in the mini projects. Okay, to call back something that we talked about with NumPy, Pandas supports broadcasting as well, which is awesome because broadcasting is the thing that makes a NumPy array much more powerful than the list. So just really, really simply, just remember that you can always broadcast with pandas, and more likely than not, you will be broadcasting something for like an entire row. So with this example, let's take a look at the year column. So the model year, and this data set has 392 rows. So this is the count, 392 rows. The mean is about 76, and it ranges from like 70 to 82. Well, because I know that this is a model year column, and let me just make sure this column name is correct. Because I know this is the model year column, sometimes, the two-digit number kind of throws me off a little bit. I don't know, maybe if this data set spans like 100 years, I might not know that. Maybe it just has some like 1970s cars, and maybe in the future there would be like 2070s cars. I just want to add the 19, the 19 before the year, just so it's more descriptive. So because broadcasting exists, I can do that very, very simply by doing cardf model year plus 1900. When I run that, you see that I get a series of all the years, but now with like the 19. If we remember what I talked about with like what a destructive function is, like with a list, we talked about this a little bit with like lists and dictionaries. What's destructive, more specific, the word is mutable. Pandas data frames are mutable. To contrast, what was not mutable was a tuple. If anyone remembers, like the round parentheses tuples, you cannot edit values in a tuple, but you can edit values in a list, in a dictionary. So when you do something like this is not a destructive method. And what I mean by that is if I take a look at cardf again, model year is back to a 2-digit number. So we have to reassign these new values. It might look like it's a little bit repetitive, but the way that we do this is we actually try to overwrite the model year column with the new model year column. So it really just looks like this. I'm reassigning the model year column with itself plus 1900. Since I run this, nothing pops out because we're not outputting anything. But if I run the cardf again, you see that we have 1900 back here. So this by itself is not destructive, but I have to reassign it to overwrite the data frame with the data that I want. It does get a little bit, annoying and repetitive because you have to keep typing. Sometimes you have to type things multiple times in the line, as you can see here, but that's part of the process. All right. So broadcasting, very, very simply, if you know you have to do something like kind of simple across like all values in a column, you can do this for multiple columns at once as well. Just remember that broadcasting is a thing. Oftentimes, not oftentimes, but sometimes if you forget that broadcasting is a thing, you end up like looping through every row in a data frame and being like, all right, for value in this column model year, do or like return 70 plus 1900, or like value plus 1900, value plus 1900. Broadcasting, again, way more efficient because in the backend, it's actually doing it all at once versus looping through one by one. Okay, the next thing I want to talk about is Boolean masking. So Boolean masking is kind of like a backend concept that's going on that allows you to do a lot of, pandas work, or a lot of filtering, or like testing conditions work. So to understand what Boolean masking is masking true false values. We're going to use this example really quick. So first, if we remember, this is how we subset multiple columns out of a data frame. So this is one way to do it. You can see here that there's like double brackets, which can sometimes throw people off. But the whole idea is to index a data frame, you need square brackets. And then here we're actually indexing for a list of columns. So that's why the double brackets usually throw people off, but that's kind of what it means. You're indexing the data frame and you're indexing it with a list of columns. So this gives us our 3 columns. This is actually the same thing as doing a dot loc. Oh, I guess not. Never mind. Oh, dot loc, that means I have to do something like this because dot loc does rows and then columns. But anyways, I usually like to do it without the dot loc because it's extra letters. So anyways, this is how we filter for several columns. So let's say out of all of these values, I just want to see which ones are even or odd. So here, what I have here that I commented out is you can actually check for conditions with entire data frames. And again, this condition is going to be broadcast over every single value. So let's take a look at what happens here. Here, I'm just checking for whether the value is even or odd. Once I run this, it's Boolean masking true falses based on whether the condition is met or not. So any false, that means that, it was an odd number, and any trues, it was an even number. So this is a condition here. And this kind of helps with filtering data frames. To make this a little bit simpler and to really nail down what's going on here, let's just do this for miles per gallon. So miles per gallon is, we have these true and false values. How a data frame filters itself, we talked about filtering last time, filtering with different conditions. How the filtering works, and again, why the syntax looks kind of weird sometimes. And actually, if it's only one column, you only need one set of brackets, by the way. Oh, something else that's interesting. If you take in a list, it returns you like a data frame type, but if you only give it a string, it sees that there's only one dimension, therefore it returns it to you as a series. For this case, doesn't matter. But let's say we have this, and let's say, all right, cool. We have the true falses for the values that are even or odd. Let's just say I want the entire data frame back, but only the rows that have even numbers. The way you do that, and I think the syntax sometimes can be kind of confusing because it looks very, very repetitive because we're using cardf twice, is this is the syntax. And I'll run it in a little bit, but what we're doing here is we're indexing cardf based on this condition. And then because it actually, what it's doing is it's actually matching up the index. So it's matching up the numbers here, and it's only going to return the rows where this index number sees true. So when we run this, we'll see that we won't have index 1, we won't have index 4. So there we go. This is just filtering the data frame for any miles per gallon is equal to an even number. And then, yeah, it matches, it's actually matching it up based on its index. Another example here, we can look at the weight greater than 2,800. Here you get, again, a bunch of true falses. And then we can use this to create new, perhaps more useful columns. So if you look at it, the output of this condition is a series of Boolean values. And the length of this series is the same as the length of the data frame. They have the same number of rows. And so this data, again, it is not destructive. You're not overwriting the weight column. So you can actually make this useful if you want. If you want to have some sort of variable that is like, or some sort of column that is true, false for like whether the car weight is heavier than 2,800, I'm guessing pounds, I don't know. We can do this in the way that we normally create new columns in a data frame. So let's just say I want this new column for like whether a car is heavy or not. All I do is create this new column of car df heavy and then set it to equal to whatever this was. And then I output my data frame, and now I have this whether it's heavy or not column, which is pretty neat. So if you know that you want a new column that is a result of some masking or mapping of anything on another column that already exists, you can use Boolean masking to your advantage. Or you can use the fact that I think it's a combination of like broadcasting and Boolean masking to your advantage. Questions or thoughts here? Okay. So the next thing we're going to talk about, and let me just like close these out so that it's a little less distracting. Next, we're going to talk about applying functions to values in a data frame. I used to get really confused with this, but there are 3 different ways to do it, and we'll walk through each of these. And you would use these for different things that you want to change. So first, there's dot map. There is dot apply, and then there's also apply map. Why there are 3 different functions and they could do kind of the same thing, just slightly differently, I don't know. But we'll talk through what these are, and like I'll mention like when specifically you would use each one, because the number of times I've Googled difference between apply and map. Yeah. All right, to start. Dot map. We saw map when we were dealing with like map lambda, or when you're mapping a function to like a thing in a list, you can use map in Python. The map function in Python is slightly different from the map function in Pandas. To be very specific, map only works on series or on single columns. There is a way I think that you can have it work on like rows of a data frame, but the easiest way to use map is for it to work on a single column of your data. And so what you're doing here is, in terms of syntax, let's say you know that you want to do a function onto one of the columns in your data frame. Think about what that function is. Let's start simple. So let's just say like I just want to map whether a car's year is greater or less than 19. I should change it to 1980 here. Let's just print out the car df just so that we can see. All right. So if I were to do this map, and I'll break down the syntax in a little bit, doing this, oh no, what happened? Model year. All right. Doing this gives me a very, very similar result as like what the Boolean masking was doing. It is doing a Boolean mask really, because we're mapping over this condition. So in a kind of similar way as like we dealt with lambda before, the syntax here is we do lambda some temporary variable. And then each of these variables, well, each y is going to point to a specific value in whatever it is that you're mapping over. So here I'm mapping over the entire column of model year. Every y is going to point to a value in model year. And then here we're just looking for any one that is less than 1980. So this is like the function or the condition. And then here we return true or false. And then again, if I want to make like a new column called like car df old car, new car. So let's just say, I don't know, this, I don't know, classic car. If I want to make like a classic car column, I can set that to be the result of this map. So when I do that, and actually, let's just rerun this, you can see that I have whether it's a classic car or not. Okay. So for slightly more complicated functions, let's take a look at car name. What's it called here? Car name. Okay. So car name, you can see here, there's like a lot of variety in the car name column. Here, we're just going to take a mini segue and just see what are some of the other like series functions that we didn't talk about last time that are going to be useful. I like unique. Unique will just show you like the list of all unique values. Sometimes when you have too many unique values, and unique just shows you how many there are. So that's kind of crazy. Like out of 392 rows, we have 301 unique values. And then another one that I really like is value counts. And value counts just sort of shows you like which are the unique values. So here you can see that there's 301 values here. They don't show all of them. But then Ford Pinto comes up 5 times, Toyota Corolla comes out 5 times. And that's just sometimes useful information. You can also put this to a graph and like graph it as a bar graph if you want. But all right. Let's do something with the car name. So you can see like there's a lot of different car names. Let's just say I want to like pick out all the Fords. You can use these map lambdas on the string, on the name column. So let me just edit this before I run it again. So I'm going to map whether the word Ford is in the name. And when I run this, you can see that like number 4 is a Ford. Is that right? 1, 2, oh, hold on. Let's look at CarDF again, just so we have that to CarDF car name. Okay. All right, so number 4 was a Ford, so that's true. 387 and 390 are also Fords. We have a Mustang and a Ranger. Perfect, so this map works. If I want to create a column saying like Ford or not Ford, I have this data right here. But we can make this a little bit more complicated because I don't want to do this for every single car brand. So to map a more complicated function, and I have an example of a function here, this is how we do it. So let's just say I mean, you can definitely work this out in more detail, but let's just pick out like I want to do Ford, Buicks, Chevrolets, and then just other. I write this function, and the function works on a value. So the function works on a value. That's important to note. Each input into the function is a value. And then all I'm doing is I'm checking, all right, if the particular brand name is in the value, return, you know, whether it's a Ford, Buick, Chevrolet, or other. It's important to know that this function works on a value, not an entire column. So you don't have to like loop through every value, or you don't have to worry about broadcasting because the Lambda broadcasts this function for you. So just to show you what this looks like, and I have to keep changing these column names, apologies. If I'm going to map this function, and this function, by the way, returns instead of true falses, it actually will return like Ford, Buick, Chevrolet, or other. Let's just take a quick look at the output. And again, because it works on a value, remember this temporary variable points to every value. I can just do car brand in. But as you see here, the result of this is I have Chevrolet, Buick, other, Ford. These are my values now. And then, by the way, you can stack these methods as well. So if I just want to see like the value counts of this, you can see that, okay, it's still majority other, but there's 48 Fords, 43 Chevys, 17 Buicks. But at this point, remember, it's still not part of our data frame. So we look at our car DF. Again, car, this column is not in the data frame yet. It's important to remember that these are not destructive methods. Like car name has not been overwritten. Car name is still the original. If I want this to be part of my data frame, car brand equals, oops, nope, that's not what I want to do. I want to do car brand this way. Add car brand as a column to this data frame. When I do that, and then I rerun this, you can see I have the car brand there. So I've added a couple of columns here. And remember, this was just showing how we use dot map on a single column. Questions at this point?
Yeah, I have a question. So after the lambda, you put n colon. What's the colon signify?
Yep. So this is just the syntax of any lambda. So lambda n is just saying for like, okay, here the n can point to anything, but this is really just declaring, hey, in after the colon, look out for n. Because there are ways to actually have multiple variables in a lambda. And it kind of like breaks us, all right, declaration, what to do with the lambda. So I think the colon just really kind of breaks it up into those two parts. But yeah, the colon just sort of breaks up like, all right, I'm declaring lambda, look out for n in the next part of this function or in the next part of this statement. If I put n here, the colon will say, all right, this is where you start looking for n. So I see n here. There are ways to incorporate multiple variables. So let's say I have like n comma m. It'll be like, all right, we're going to declare our temporary variables are going to be n and m. Maybe it's someplace here. I don't know. Maybe I'm going to do like some function with m. Very unlikely you'll use like multiple variables in a lambda, but that's what you would use it for. And that's kind of like why we need the colon there to divide it.
So
Because
it's like yeah, it's like a slicing type of method, like the other ones, or is it
not? That's an interesting way to look at it. It's not exactly slicing. Yes, for most of the time we have seen the colon for slicing, but in this case, it's just like, hey, look over here. You know, it's more of like what do you call it? It's like sort of like key value, but I wouldn't think of it as slicing. It's just be like, you know, when you have a form and you fill in like your name and like your stuff like that, it's more like that.
Okay.
Yeah.
All right, thank you.
You're welcome. I would say like getting used to using like lambdas with like maps and applies. That was something that for me, I did have to like practice a bunch and like work with a bunch of like data cleaning projects to find points where like, you know, at one point I had to clean like a 6 million row data set. And I was actually looping through everything. I was like, wow, this is taking like, it took like 7 hours, I remember, to like me sitting at my computer. I didn't sit for 7 hours, but like the computer was working on like editing everything. The 6 million rows, it took 7 entire hours. But if I had done it with like a map, it would have been a lot faster. So that's like one heavy use case. I mean, most of the data sets we'll be dealing with at this point won't be that long, but just so you all know, anytime you're using a map, it is making use of the broadcasting ability. So it will just be a lot more efficient. At this point, efficiency is not the most important thing. I think the most important thing is getting, you know, being able to get the result you want. But, you know, as you get more experience, you definitely want to focus on, you know, doing things quickly. If not, you just have to sit and wait for something to finish executing and running. Okay, so that was .map. And just to reiterate, .map works on a series, only on one column. Okay, so next we're going to talk about .apply. And .apply works on an entire data frame or on multiple columns of a data frame. Before we talk about .apply, the one that's like kind of in the middle is called apply map. Apply map is probably one that's used a little bit less, but apply map is like .map, but you can do it on an entire data frame. Apply map, I would say, is if your entire data frame, you want to do the same function for everything, you use an apply map. Not many cases you would get to be able to use the same function for everything, because here, you know, we have different data types, right? We have a combination of like integers, floats, strings, and booleans. Very unlikely will you get a data set that's all the same data type. And very unlikely you'll want to do the same thing with the entire data frame with the same data type. But as a quick example, let's just say I want to turn everything into a string. That's one thing that you can do here. Probably you won't need to. And if you have these numbers, why would you turn them into a string? But just to show the functionality of apply map, turning this into strings. So apply map works very, very syntactically similar to .map. I take in like the value, again, this temporary variable can be anything. And I apply map a function. And here the function, I'm just going to turn everything into a string. And you can see here, yes, it looks the same. But if I do like a dot info, everything is now an object instead of a, let me go back to cardf dot info. Here we had like some floats, some ints, booleans, objects. But here when I did this apply map and I did a dot info on the apply map, everything became a string. So let's just clean this up, get rid of the dot info real quick. So for example, after doing this apply map, if I were to look at the column displacement, you can see that these are objects. Each of these is actually like a float. It's a string of a float, which, you know, you cannot do mathematical operations on this anymore because I turned it into a string. But again, remember that this isn't destructive. Even though I've done this apply map, nothing has changed with my original data frame. So my original data frame still has all the different values. I mean, kind of looks, still looks the same, but if I do my dot info on my original data frame, I still have my different data types. If I call this like car string data frame equals to this, sure, my car string data frame will be the one. Info will be the one that has all of the strings. I could also decide to overwrite cardf, but I do not want to do that right now. But that's what apply map does. If you want to do the exact same thing to every value in your data frame, you would use apply map. Just to show another quick example of how you can use apply map, if you know that you want like a subset of your data frame, so let's just take a look at our cardf real quick. So let's just say I have my my Boolean data frames, and for some reason, it's easier for me to work with my Boolean columns as strings. You can use apply map as a subset if you first subset it into a data frame. So what I mean by that is, let's say I have my heavy and classic car. So to subset these two data frames, I have to do the double list of heavy and then classic car. Go. So here I have my two columns here. The result of this is a data frame. So I can apply map here. Lambda Boolean equals to a string of Boolean. And then so now if you look at this, these are now objects. Before they were Booleans. So if you want to do like an apply map, but only on like a subset of your columns, you can sort of like the loophole there on that you don't, you know, if you know you want to do it on like, let's say like more than half of your columns, you can do it this way rather than, you know, doing it for each column one at a time with a map. So there's like a little loophole. Okay. Questions about that? I would say apply map is not used as often. Okay. So next I'm going to talk about dot apply, and dot apply is the one that I actually use the most. To be honest, probably because for dot map, all of these things, I actually don't really need the dot map. What I mean is, like, if I want to do, let's say just forward in n again, and I have car df car name. Oops. What did I call it this time? Car name? Okay, yeah, car name. This is kind of synonymous to, I think if I do forward in car name, same thing there. Oh, I guess not the same, but never mind. Usually a lot of things that I can do here, it will be broadcast. Broadcasting did not work there. I don't want to get into that right now, but a lot of things can be broadcast if I'm doing a dot map. But anyways, I like to use dot apply the most. Where was I? Because dot apply allows you to use multiple columns in more intricate ways. So the way that I do this, let's just say I want to create a new column called horsepower per weight, and several things I'm going to print first. These are all the columns in my data frame now, and this is my car df again. So let's just say I want to create this new feature or new column called horsepower per weight. Through any like simple mapping or apply map, I can't do that because, you know, map only supports one column. Apply map just does the same thing for every column and every value that's in my data frame. Apply gives you the functionality to, you know, do this divided by this, which is pretty neat. So how we use dot apply, syntactically, when I'm doing like the dot apply, this part is very, very similar as we talked about with like dot map, apply map. Again, it's a syntax that just takes a little bit of getting used to. But I define my function this way. Remember how before when we talked about dot map, when we talk about dot map, each input is the value. For dot apply here, for dot apply, each input is a row. For my own like for me, to make it easier for me to like keep track, I literally call the argument row. So each this function will just work on a row, and it works on the row, and it also is able to recognize the column names per row. So horsepower per weight, and of course you can get more complicated with this in the same way. I want to use horsepower divided by weight. So I define this function, great. And then I want to apply this function onto my data frame. So the way I do that is, see, this function is called horsepower per weight. I'm going to do lambda r for row. It's just, again, I chose the words row and r, so it's because it's easier for me to figure out what's going on. I do lambda r, apply the horsepower per weight function on every row. And actually, you have to tell it axis equal to 1. Axis equals to 1 just tells it to work on every row. Pretty neat. Actually, if you do a dot apply with axis equal to 0, it's going to work on every column. By default, it's axis equal to 0. I typically just use axis equals to 1 because usually you want to do your functions column wise versus row wise, but that's just the syntax here. I'm going to apply horsepower per weight. And then great, I have this horsepower per weight column, again, not destructive. So when I have this and I want to add it to my car data frame, I'll do horse per weight. I need to be more consistent with the naming. Actually, it's good practice not to use spaces, so let's not do that. Good practice not to use spaces in any names. It's just that the ones here already had spaces, but whatever. All right. So we look at CardDF, I have this new function, new column of horse per weight. Of course, you get way more complicated with this. Let's say you want some fancy function. I don't know, maybe there's some sort of formula for calculating, like, I don't know, the overall strength of a car that includes like, maybe it's like, I don't know anything about cars, but maybe it's miles per gallon, divide by cylinders plus displacement, like minus horsepower. If the value exists in the data frame, you can use it in the dot apply. And you can apply it per car, per row in your data frame. So this is a pretty simple example, but you can very, very easily build on this. If I want to do a horsepower divided by weight minus, I don't know, minus acceleration divided by model year, that's something that you can do. So that's dot apply. I will admit to you all that like for dot apply, I wrote it once when I was a student. And every time I knew I had to do something similar, I would go back and I would copy these lines of code and then go back and like edit it for my own fun, because I don't know for what reason, I just could not remember the syntax of this. So very, very okay. Like you don't have to always remember, okay, each one of these is going to work in the row. How do I apply it? What is the exact syntax for like, row axis equal to 1? So completely okay. I know some students like to have like a bank of like commonly used functions that like they just put in like a text file or a notes file somewhere, and they just reuse as needed. No shame in that. There's absolutely nothing wrong with doing that. All right. Any questions at this point before we move on to the next few things?
I've got one actually. So I guess every single row is also its own separate data frame with like columns and everything like that.
Yeah, you can sort of think of it like that. Because it's broadcasting. I mean, technically, yeah, if I were to do like .ilook and I look at like 0 to 1, this, yeah, every row is kind of like, it can act as its own separate data frame. In the backend, it's actually doing like something very similar to like a list of dictionaries. I don't know if that's more helpful to think about it or not, but these are keys and these are values. So that's one way to think that you can also think about it.
Yeah, I never actually noticed it before. I wouldn't have thought to use that kind of function.
Yeah, it's pretty neat. But yeah,
Thank you.
You're welcome.
I got a, yeah, So for a dot apply, is it sort of mandatory that you have to use a function prior to using dot apply?
Oh, good question. Not at all. Not at all. I could have actually done this as like cardiac. Let's see if I get this right on without looking it up. But if I do like dot apply lambda r, and let's just do a different one. So let's just say I wanted to do r, I don't know, cylinders plus r origin. I can do it like that as well. X is equal to 1. If I do this, you can see that it does it for me as well. So yeah, you actually don't always need to have like a function defined. I just sometimes, for me, I find it a little bit easier to use a function, but yeah, you actually don't need one. If something is simple enough for you to like write out in one statement, you don't have to use a function. That's a good question.
Would it still, would you still be able to like create a column?
Absolutely. Absolutely. So if I do like cardf, I call it maybe cylinder origin. Yeah, let's just call it cylinder origin for now. Yeah, you'll see that I have that there.
Oh, wow, okay.
Anytime that you see something like this output, anything you see like an output of like a series, you can just copy and paste or like, you know, take whatever this is and then add it to the data frame. So this can be like as complicated to me, like a really, really long line. I can even, let me just try this. I think I might be able to take this and like multiply it by 2 even. I can do this and like just do like, I don't know, cardf. This is going to be a very big, messy data frame at this point, but maybe it's cylinder origin times 2. I can do that as well. So yeah.
Oh, wow. Thank you.
You're welcome. Anything else before I move on to the next thing? All right. Well, the next thing is we want to talk about Groupbys. I feel like the group by name is sometimes misleading because people think that, yeah, you're doing Groupbys to group your data, which can be sometimes confusing because you're like, anytime you want to group your data, I have to use a group by, which is not necessarily true. I think a better way to think about group by is whenever I want to like aggregate my data in groups. So I call it group by methods for aggregation. Group by is going to come back when we talk about SQL next week. And group bys are actually a really, really common thing to use when you're like exploring your data, especially when you have, you know, a bunch of unique values. Whenever you use a group by, you have to pair it with an aggregation function. A group by itself is not going to do anything. So that's why I feel like group bys, it's better to think of it as like when I want to aggregate something within groups, that's when I use a group by. So yeah, to get aggregated information about subsets of your data. So let's look at our cardf again. I have all of these. Group bys work. I mean, they work on any column. Usually people use them for numerical columns, and I'll show you why. So let's just say that, you know, I have these different cylinder values. Let's just take a look at what values of cylinders I have. Maybe I just want to do like a bit of exploration of like, okay, is it true that the more cylinders I have, is the, I don't know, miles per gallon higher? I don't know if that tracks with cars. I don't know anything about cars, but let's just take a look at the value counts. So, all right, so it looks like I have like the cylinder values. I can get like 4, 8, 6, 3, and 5. And the most common one, I have like 199 instances of like 4-cylinder cars. So let's just say I want to find like the average value of miles per gallon for each cylinder value. How you do that is with a group by. So the syntax for this is like, all right, I want to see the value for each cylinder. So I group by cylinders, and I'm going to take the mean, and we'll take a look at what this outputs. All right, so you know we have each of these unique cylinder values, and I actually have the mean of any numerical column. So here you can see that for 3-cylinder cars, the average miles per gallon is 20.55. For the 4-cylinder cars, average miles per gallon is 29. So just like this is a really, really quick way to see, all right, per cylinder, how do my other values track on average? So what is happening here is that in the backend, the data frame is just picking out, all right, I have 5 different groups of cylinders based on the unique values. So I have like 4, 8, 6, 3, and 5. Those are my different cylinder values that a car can have in this data set. We're sort of going to isolate each one and then average all the other columns based on each cylinder value. So with this output, actually, you can sort of see that like it looks like, you know, and good thing these cylinders are in increasing order. So let's see, the displacement increases with the number of cylinders. You can see displacement goes up the more cylinders you have on average. Remember that this is just the mean value. Let's see, the weight gets heavier roughly. I guess 3 is it goes a little bit heavier than 4, but I mean from 4, 5, 6, 8, it gets heavier. Doing a group by like this, you can really see some like good overall, I guess, statistics or numbers regarding your data. So it's pretty neat to do group bys. If you see that this output is actually a data frame as well. So if I didn't want to, let's say I had like 100 columns, which is very, very possible, and I just want to subset it, you can subset this as well. So let's just say I want to look at like, I don't know, miles per gallon. Let's say I also want to look at, I don't know, horsepower and like weight. Because this output is a data frame, I hope this works. There we go. I can just subset it to just look at the specific columns, just so it's easier to inspect. And then you can also plot this as well. And plotting we'll talk about at the next study group. But yeah. So this is just a group by. Let's just say I just want to look at, you know, how the numbers change between each car brand. Of course, here I only have 4 different unique values for a car brand, because of the way that I wrote my function earlier. So I have my others, my Ford, Chevrolets, and Buicks. If I want to do that, I can look at group by car brand, mean. Cool. We can see that, you know, all the other cars on average have a higher miles per gallon. It looks like Buicks have like the highest displacement. Of course, if I had like broken up the brands even more, you can get, you know, it becomes a little bit more informative. But yeah, this is how a group by works. Here I've been using the average, and mean is not the only function that we can use. I have this here. There are other aggregations that you can use. There's min, max, median, mean, count. All of these are like aggregation functions. Anything that looks at a group of data and returns you one value, that is an aggregation. Usually mean is the one that's used the most, sometimes median as well. So let's just say instead of mean, I want to check out the median per car brand. Cool. So the median numbers, I mean, it does depend on the distribution, whether the mean and median are going to be similar or not. You can see that in terms of median, the model years are all kind of similar. Median horsepower, Buicks are the highest, so on and so forth. Maybe I want to look at min and max. Maybe I want to see if like, I don't know, maybe there are like some outliers that I just want to be aware of. The minimum values, origin is 1. Something else to note is that, as you can see here, we have our Boolean columns here, and false, if you remember, false is 0, true is 1. Mathematically, that's what's going to happen here. So if I were to do, let's just go back to mean and take a look. Heavy was true, false. Classic car was true, false. When you take the mean of a bunch of trues and falses, or 0s and 1s, basically this is saying that like about 82% of, let me zoom in. I feel like this is kind of small. Where was I? All right. 82% of all of my Buicks were heavy. That's just one way to interpret it, because 0.82 is the average. So about 82% of my cars within Buicks are heavy cars. That's just one way that you can also interpret, like when you aggregate over a Boolean value. We'll get more into group bys, and you'll have the chance to practice more with group bys in the topic 5 mini project. But also when we get to SQL, we'll see group bys as well. Group bys is a pretty common interview question, and I know it takes a little bit of time to like get used to, all right, what exactly is a group by used for? Again, I think it's important to think of it not as like, okay, I'm just grouping my data, because grouping is different from like aggregating. So I like to think of like group by as like, I want to aggregate my data within each group. I use a group by. If you just want to like separate your data into like different subsets, that's like a common thing that people mistakenly use group by for. So yeah, just so that you all are aware. Okay. Questions about this before I move on to the last thing, which is combining data frames.
I have one quick question, just to make sure I have it right. So it's basically you take a category and you're basically aggregating the totals in each other category for that specific category. Is that
Absolutely. That's right.
correct?
That's right. So like as another example, another aggregation is sum. Let's say I just want to find like the total for everything. Of course, because other, I have a lot more cars than other, the sum's going to be higher. But yeah, let's just say like I just want to see the sum of everyone who, maybe this is not a good example, but maybe the sum of, the model year, maybe. I don't know why that would be useful, but just an example. Yeah, I can see like for each year. Oh, that's actually a pretty neat one to look at mean for. Like if I look at the mean within each model year, like how does miles per gallon change over the years? It looks like miles per gallon is getting higher on average as the years, as the years go by. But yeah, you're right in saying that, we're looking at each category within a column. So within the column that you pass into the group by, you're just looking at aggregations of those values.
Thank you.
You're welcome. If you don't put an aggregation, you'll get a generic group by object, and there's no information here. So yeah, what other, count is a pretty neat one. If you just want to see like how many there are, you can see that like there's like 40 1973s. What's the least? What's the smallest number? 26? Yeah. So these are aggregations. All right. The last thing we're going to talk about is combining data frames. Very, very quick example. I will say combining data frames, I don't know why, but Pandas has a lot of different methods that do very, very similar things. There is concat and there's join, and there's actually also merge. And I think I link it somewhere here. Merge. Oh, there's also missing data. Okay, hopefully we have enough time, but I have no meeting after this, so we can go a little bit long. Yep. Okay. So there's concat, join, merge. If you ask me right now what the difference is, I cannot tell you. It's something that I always have to go and look up. So because of that, I've linked the documentation to concat over here. I like Pandas documentation because I think Pandas documentation gives you a lot of examples. And this example, I think in the notebook, I actually took from here. This just shows you different ways that you can concat your data frames. So as a very, very quick example, we're going to use these 3 data frames that have these values. So we have these data frames, data frame 1, 2, 3, they look like this. I actually learned a better way to do this. If you do display df1, I don't know if you all are aware of this. I found out about this like within the last year, honestly, which I should not have, I should have known. But if you do this, you can actually output multiple data frames in a cell. So maybe this will be helpful for you. You can display data frame 1, 2, 3. And that's just because the way that Jupyter Notebook works, it really only outputs what the very last line in the cell is. And so I don't have to put display around the last one. But you can see here, this is output. But anyways, let's just say I want to put these together. If I do pd.concat, it just joins them all together by default. That's how pd.concat works. As an example, I have this other data frame. And so let's say that this one's a little bit different. If you can see here, I have like columns B, D, and F. Here are my columns A, B, C, D. If I want to put them together, but side by side, because here what I did was top to bottom, I put them on like vertically. If I want to put them side by side, I can also use the concat method, but with like different kinds of joins. We'll talk about joins a little bit more when we get to SQL. And joins is really something that it's like trial and error. I think you I think joins, there are a lot of like good graphics. I think in the, when you look at the labs, they have like good graphics to show you like how to interpret a join. For me, it's really, I mainly try like different kinds of joins and see which one is the one that I want. But what I'm doing here is I put them side by side, and depending on the kind of join, it puts it side by side in different ways. So here, as you can see, I have A, B, C, D, B, D, F, and they've put them side by side here, but only 2 of my rows are kept. And that's because I did an inner join. Before I talk about that, the reason why it knows to put it side by side or like top and bottom is based on the axis. So by default here, I mean, I didn't put the axis here, but the default is axis equal to 0. And so that's why it does it top to bottom. I think if I look over here, axis to concatenate it along. Do I concatenate along by the index or by the columns? But yeah, the reason why it knows how to do side by side is because I put axis equal to 1. And then we talk about the kind of join. If I look at pd.concat and I look at join, you can do inner or outer. Inner basically keeps the index numbers that exist in both. So here you can see it only returns row 2 and row 3 because both of these data frames have 2 and 3. So that's why when I do an inner join, it only returns the 2 rows and all of the rows values are filled in. To contrast, if I do an outer join, it looks a little different. It has my 2s and 3s because my row 2 and row 3 because, you know, all the values are there. That's not surprising, but it still preserves the other data. It preserves the other data by just filling in NaN values into the, you know, in my, in this data frame, I don't have 6 and 7, but they just fill it in with null values here, 6 and 7s. So that's the difference between an inner and outer join. When you want to use which really depends on the question. I think as you're going through, you know, a data cleaning project, and then if you, and I do know that the topic 5 one also has you joining some data frames. You get to make your own decision on, okay, does it make more sense to do an inner join or outer join here? Am I going to just lose rows? Because sometimes you want to preserve as many rows as possible. Maybe you do an outer join and maybe you like do something about the null values. Or if you feel like, you know, I don't want to have to take into account these null values, maybe I do an inner join. There's also left join and right join, but that we'll talk about another time. Cool. So yeah, you can supply the join argument to pd.concat. Other than pd.concat, which is pandas.concat, there's also a dot join method that kind of does the same thing. I don't have an example here, but it does pretty much the same thing. So I know that there are scenarios where join will work where a concat won't, concat will work where a join won't. What those scenarios are, I don't know off the top of my head. Sometimes when students are doing like a fairly complicated joining task, if one doesn't work, they sometimes just try the other and figure out what works then. So unfortunately, I think it's a trial and error thing, or maybe you want to look into documentation and figure it out. I don't know. On top of that, there's also Pandas Dot Merge for some reason. PD Dot Merge, I actually end up using this one the most because I find that merge encompasses the capabilities of a join and a concat. I'm not sure why exactly, but there are basically a lot more parameters in a merge, and I'll show an example in a little bit. But basically, when you know that you want to put 2 data frames together, just know that you have all of these options. I think it's just important to know that, you know, there are many different ways that you can put them together. Okay. So here you can see that this was the same thing I did before. As I did before, I outer joined my df1 and 4. I'm going to do the same thing with a join here. Actually, wait, let's turn this back to outer so it matches. Okay, so this kind of gives us the same result. Here, as you can see, there's an R suffix. And if I don't have this R suffix, it gives me an error. And I hope it says, yeah, columns overlap. So we're providing this R suffix, as you can see. Oops, what did I do? We're providing this R suffix because it knows that, all right, hey, you have some like potentially clashing values with like your B and D columns, right? Because both of these, B and D, these match. This can potentially be very, very, this potentially can be really messy because I want a subset B, it will give me 2 columns, which in this case, sure, I mean, these values are the same anyways, but it's just gonna complicate things. So join will allow you to give it a suffix. Actually, let me see if concat allows me to do that too. Yeah, I guess they don't give you like the suffix ability for concat. Okay, but anyways, for join, it allows you to give that suffix there. Just as a quick show, just to show you all quickly, a left join looks like this. The NaN values are on the right side table. And if I were to do a right join, the NaN values will be on the left side of the table. That's just really quickly, very, very briefly, what the difference between the left and right join does. Concat also does not have the capability for left and right join. So that's another difference. All of these differences are I only know because I'm seeing them right here. But Pandas Dot Merge, that one I know you have all the capabilities to like adjust here and there. But yeah, putting data frames together. Moral of the story, lots of different ways to do it. Different methods have like slightly different arguments that you can feed it. I feel like it's more of a matter of like your experience. You figure out which one you're most comfortable with. Yeah. Okay. Questions about putting these together? I can show you all very quickly a Pandas Dot Merge. Let's see, let's just make sure this is right. Okay. So when I do this, I believe I get an error. Okay, because the join is on here, the argument is how. There we go. And then I guess there's no axis. Okay. So why I like join is because I like that I can tell it which column to join on. So I think I can do right on D. Okay, never mind. Let's just see if this will work. Okay, never mind. I cannot do this right now, but merge basically gives you very similar results. You just have to say, all right, left on which column, right on which column. Here you can see that I have like suffixes. This one is a little bit more complicated because there are so many arguments. But yeah, just so you all know that this one also exists. Okay, the last thing we're going to talk about is missing values. So I don't like to see this here. So let's look at the missing data. All right, so with missing data, and we're going to use this example here because this is the data frame that just has null values. Okay, and what I did was I dropped B and D just so that we don't have the clashing column names. So we have 3 columns here, each with a couple missing values. I talked about this the last time, but I just like to use the isNA.sum, especially if you have like a very, very big data frame and you want to just see what your missing values are. IsNA.sum will tell you, all right, A has 2 missing values, C has 2, F has 2. If I do sum again, it tells me the total number of missing values. But I think this is a little bit more helpful. So we have isNA, and then we also have fillNA. So fillNA is something that's pretty useful if to just fill your null values in different ways. I like this documentation page a lot because it shows you all the different ways that you can do it, right? There's one backfill, pad, forward fill, so on and so forth. And here you sort of see the different ways that you can use fillNA. So here you can see that, like, all right, let's say for different columns, you want to fill them with different specific values. A, B, C, D, you're going to fill it in with 0, 1, and 2, and 3. You can forward fill. So that means like you fill a null value with the value preceding it. Just a lot of different ways to do filling of null values. And you can also write functions to fill your null values in specific ways as well. So just as a quick example, fillNA, I can fill it with 0. Again, this is not a destructive method. So if I look at test again, the null values are still there. If I want to actually keep, the zeros there, I have to overwrite or create a new data frame and assign it to a new variable. And then also a little more complicated, a slightly more complicated one, I am filling it with specific values. So you can see here, what I'm doing here, I'm declaring a null value filling dictionary, which basically says that, all right, for every null value in A, fill it in with 3, every null in C, fill it with 2, and then every null value in F, fill it in with 4. And then when I fill in A, I say value equals to this dictionary. And then that does that, that custom filling. Something that's also pretty useful, and there is actually a couple labs that go through it, like you can fill in the null value with like the mean of that column, which is usually pretty helpful, mean or median of that column, which is pretty helpful. There are a lot of philosophies and methods that you can go about with filling null values that I think you just slowly build up over time. I think it's important to think about your context of, you know, if I want to fill the null values of, let's say, the ages of people, does it make sense to use the mean? Especially if it's like, maybe it's a data set that skews, like maybe there's a lot of children, a lot of old people, does it make sense to fill in the mean? So those are all questions that you should ask yourself. Like, does it make sense that I'm filling these null values with this value? And when you're doing your data cleaning in like with a narrative, I think it's easier to think of and come up with these situations. One final thing I wanted to talk about is all of these were not destructive, right? Even not yesterday, but even in our last study group, we talked about all of these methods that are not destructive. And I always say that, you know, you have to like reassign your data frame. Like I would have to do like, oh, test equal to test fill in A, blah, blah, blah. There is also, let me just make sure that fill in A has this as well. Okay, so a lot of pandas functions are not destructive, but a lot of methods have this one argument called in place. So you can see here, fill in place, this will modify any other views on this object, which basically means that if I don't want to have to keep overwriting my data frame with a new one and keep like reassigning my data frame over and over again, you can do in place equal true. So here you can see that I just ran this test and the null values are still there. If I did this fill in A with the argument in place equal to true, let me just make sure that that is right. Okay, sometimes I forget there's an underscore in place, right? If I do in place equal to true, one, it doesn't output, but then when I rerun test again, and this is test again, I didn't have to do test equal to test dot fill in A, blah, blah, blah. I would say this is a little bit more dangerous because it's harder to undo stuff, right? Because if this test has already been changed, like where am I going to find the data frame before this has been changed? This could be something that you do, like, you know, after you figure out all of your cleaning that you want to do, maybe you go back and adjust your code and clean up your code and have it all have in place equal to true. Maybe you do that. But yeah, pros and cons. One, you don't have to write another line of like, you know, this equal to this same thing, but it becomes a little bit harder to revert your data frame back to the way it was before. So just something that's good to be aware of. All right, this is all I had to share for today. These are kind of like the main processes that you would take when you're cleaning any data frame. Really, what exactly you do with the data frame, it's really up to you. I think, you know, data cleaning sometimes can be an art form in which like you get to make your own decisions based on how you think people are going to use the data. So do keep that in mind when you're going through like some of the mini projects or even your own project at the end of the phase. Would love to talk about in one-on-ones, either one of the, here it says there's like the data cleaning. Oh, I think I called it, it's named something different now, but let me just pull it up real quick so you all can see the ones that will be good to go through. And I would really love to see what your processes are like. Let me just look at student view real quick. All right, the good ones to look at are either the mini project here, EDA with pandas using Ames housing data. It's basically a housing data set. EDA stands for exploratory data analysis, and I'll talk about that on Tuesday when we talk about visualizations. Or I guess and/or, you can do like the mini project on data cleaning here. This is actually a data set where you would have to join two data sets together. And then I believe it's like a data set of like superheroes and like their powers and like stats about superheroes. So if you're interested in that, that's there. All right. I think those are two good ones to work on. Whether you work on that this week or you wait until after, I get that's also this week. So you feel free to wait until after the visualizations to start back on it. I think like, you know, the order in which you do these labs really, really doesn't matter. But yeah, I think that would be a good one to, if not talk about with me, go through on your own, because it will be very, very good practice for the end of phase project. I will tell you all now, but feel no pressure to have to do this. After topic 6, you can pretty much do the project. We do have 2 weeks to do that project, but feel free to start on it early if you want. I will have a session explaining what the project is when the project dates are actually, you know, when it's time to do the project. But if you're curious about what the project's about, what you might have to like brush up on or prepare for the project, I would say the main focus is still going to be like topics 3, 4, 5, 6. But it is here. Is it here? Oh my gosh. I'll put it on here, but it should be, oh, here we go. Yeah, it is here. Milestones, it's under milestones. So if you take a look at phase 1 project, the prompt is there. So if you want, you can like read about what the project's all about. All right, well, that is all I have for you all today. Any questions before we wrap up? Cool. Let's see. Yeah, I don't think I have anything else to say. So in that case, I wish you all a good rest of your Sunday. I will see you all back here on Tuesday. Remember that Wednesday we don't have a study group because we moved it to today. All right, well, have a good rest of your weekend, and I will see you all at your 101s this week. Bye, everybody.
Hey,
All
everyone.
right,
Bye,
thank you.
guys.
Thank you.